Hey everyone. Oh Allah, guide me and guide through me. اللهم لا سهل إلا وجعلته سهلا وجعلت الصعب إن شئت سهلا. Today in this episode we are gonna talking about photoelectric cells. First of all, we are talking about uses for this phenomenon. It converts light energy into electric energy as in photosensor, like in opening and closing the doors, and generate electric. The scientific base for this theory: the emission of electrons from the metallic surface due to falling of light on it. We called this photoelectric effect. The structure of photoelectric cells. The photoelectric cells consist of tube of transparent material which is evacuated from air and consist one cathode, which is a concave metallic surface that emits electron when it exposed to light. Anode. Number 2, anode, which is made of thin wire to avoid shedding the light which fall on the cathode. The anode pick up the electrons emitted from the cathode, causing current in external circuit. Okay, the light falls in the surface, metallic surface, cathode. We observation the emission of electrons depends of the frequency of the incident light. Frequency of the incident light, not the intensity of the light, such that electrons will not be emitted until the frequency of incident light becomes greater than equal. Again, the emission of electron depends of the frequency of the incident light, not the intensity of light, such that this electron will not be emitted until the frequency of the incident light becomes greater than or equal to certain value, which is called the critical frequency. Critical frequency, however, is the intensity. Depends on frequency, not intensity. The definition of critical frequency is the minimum frequency the incident light requires to make an electron get free from the metallic surface without gaining kinetic energy. Number 2, if the frequency of incident light wave is equal or greater than the critical frequency, then the intensity of the photocurrent increases by increasing the intensity of the incident light due to increasing the number of incident photons on unit area of the surface per second, which increases the number of electrons that escape from the surface. Okay, so when increasing the intensity of the incident light, this due to increasing the number of incident photon on unit area, okay, the surface per second. Number 3, the velocity and the maximum kinetic energy of emitted electron depend on the type of surface material and the frequency of incident light and not its intensity. Okay, depends on the velocity and the maximum kinetic energy of the emitted electron depend on the type of the surface material and the frequency of the incident light. Okay, not intensity, absolutely not intensity. By increasing the frequency of the incident light at constant intensity, the maximum kinetic energy emitted electrons increases, but their number remains unchanged because the number of photons of the incident light did not change, so the intensity of the photocurrent remains consistent. Okay. Number 1, the maximum kinetic energy and velocity increases by or depends on surface material and frequency, not intensity. Then number of electrons increases by increasing the intensity or increasing the number of photon of the incident light. Okay, when it change the number of photon, then the number of electron change. Okay, Einstein explanation of the photoelectric effect. Einstein but an attribution for this phenomena which led him to Nobel Prize in Physics in 1921. Time, but an attribution for the phenomena which led him to Nobel Prize in Physics in 1921. He explained the photoelectric phenomena. Radiation consists of small packets of energy each. Each of them is called quantum or photon. This this sentence or this expression, Planck assumption. Planck assumption. A certain a certain amount of energy is needed a free electron from the surface of a metal called the work function. Work function is determined from the relation work function equal Planck constant time critical frequency equal h times c over critical wavelength. Again, work function equal h time critical frequency equal h time c over or divided by critical wavelength. Einstein said we have three states for function for work function. First, when the energy of photon less than the work function of the surface. Okay, in this case the frequency of incident of light, the frequency of the incident photon on metallic is the frequency of the in this case less than the critical frequency. Okay, less than the critical frequency. We noticed the electron would not be emitted at all, no matter how intense their incident light or the period of time exposure on the surface. State number 2, if the energy of photon equal the work function. Okay, the frequency in this case equal to critical frequency. Okay, equal to the critical frequency. We noticed the electron will be parallelly set free from the surface without gaining any kinetic energy. Okay, state number 3, greater than when the energy of photon greater than the work function. The frequency greater than the critical frequency. In this case, we noticed the photon free an electron from the metallic surface and the energy difference appears in the form of kinetic energy gained by the electron. Okay, we'll summarize this states. State number 1, when the frequency less than the critical frequency. In this case, the electron would not be emitted. State number 2, when the frequency equal to the critical frequency. In this case, electron will be parallelly set free from this surface without gain any kinetic energy. State number 3, when the frequency greater than critical frequency. Frequency greater than the critical frequency. The photon frees and electron from the metallic surface and the energy different. In this case, the kinetic energy gained by the electron. Okay. Then the definition of work function of a metallic. It's a minimum energy needed to free an electron from a metallic surface without letting the electron gain a kinetic energy. Then the definition of the critical wavelength, it's the maximum wavelength of the light falling in the metallic on a metallic surface to free the electrons without letting them gain a kinetic energy. The aim of this episode, I wish to understanding this phenomenon, and we know what we use this for this phenomena and scientific base and structure of photoelectric cells and what Einstein attribution.